What's inside a black hole?
So we have equations tell us what's in a black hole. So it tells us that within a black hole, a whole new space-time can open up in the future history of this universe. And by that reasoning, we in this universe may be the other side of a black hole that lives in somebody else's universe.
Around 13.8 billion years ago, the Big Bang marked the beginning of our universe. From that point on, the universe expanded, galaxies formed, stars were born, and planets emerged. Life eventually emerged on one of those planets, namely Earth, and it has evolved to become self-aware and curious about its origins and place in the cosmos. However, what if everything we know about the universe's origin is inaccurate? What if the Big Bang is not the start of the universe? And what if the cosmos we observe is merely the outcome of being inside a black hole that originated from a parent universe? If black holes in our universe can give rise to baby universes, then our entire cosmos may be the result of another black hole. Some may wonder what the reasoning is behind this claim, and what it implies if we are indeed residing inside a black hole. To delve deeper into the latest theory that the Big Bang may not be accurate, we must first rewind the clock before humans existed, before the Earth and the Sun formed, before galaxies emerged, and before light could shine. According to many physicists, there is no before the Big Bang as time began at the moment of the explosion. Therefore, pondering anything earlier is outside the realm of science. We may never know what reality was like before the Big Bang, what it was composed of, or why it erupted to give birth to our universe. Such ideas are beyond human comprehension. However, some scientists disagree. They theorize that a moment before the Big Bang, all the nascent universe's mass and energy were compressed into an incredibly dense yet finite seed of a new universe. This seed was likely trillions of times smaller than any particle humans have ever observed, but it can trigger the production of every other particle, galaxy, solar system, planet, and even living beings. If there were a God particle, this could arguably be it. Interestingly, this suggests that if we are indeed living inside a black hole, our universe's structure and laws of physics may have originated from a different universe. The implications of such a concept could be significant in expanding our understanding of the universe and our place within it. The question then arises: how was this seed created? One idea that has been debated for many years, most notably by Nikodem Poplawski of the University of New Haven, is that the seed of our universe was created in the ultimate kiln, inside a black hole, probably the most extreme environment in all of nature. It's essential to remember that over the last few decades, several theoretical physicists have come to believe that our universe is not the only one. Instead, we may be a part of the multiverse, a vast collection of separate universes, each a shining orb in the true night sky. This leads to another related idea made famous by Stephen Hawking. Each time we create a black hole in our universe, it could give rise to a baby universe that's only observable to an observer who crosses inside that black hole's event horizon. So could our universe have been spawned by a black hole created in some grandparent universe? And do we give birth to a new universe each time a new black hole is formed? The defining characteristic of a black hole is the event horizon, a boundary that tells a different story for an object outside of it than for one inside it. Outside a black hole's event horizon, any object will experience its gravitational effects, as the space is curved by the black hole's presence. However, it can still escape if it moves quickly enough or accelerates rapidly enough in the proper direction. It won't necessarily fall into the black hole, but it could break free of the black hole's gravitational influence. On the other side of the event horizon, though, an object is immediately doomed to be consumed by the black hole's central singularity. To someone outside the event horizon, the black hole appears to grow over time as it gains mass. But what if our entire universe is inside a black hole? The theory suggests that if black holes that form in our universe give birth to baby universes, our cosmos might be nothing other than the product of another black hole. The idea that our universe might be the interior of a black hole is known as the black hole cosmology theory. It suggests that the Big Bang, which is the origin of our universe, was the result of a gravitational collapse of a star in another universe. This star collapsed to form a black hole, which in turn spawned our universe. According to this theory, the singularity at the center of a black hole is not a point of infinite density and zero volume, but a region of space that contains a new universe. The idea of a black hole being the origin of our universe is supported by several pieces of evidence. One of the key pieces of evidence is the similarity between the observable size of the universe and the short-scaled radius of a black hole with the mass of the observable universe. Another piece of evidence is the fact that the cosmic microwave background radiation, which is thought to be the afterglow of the Big Bang, has a particularly perfect black body spectrum that is consistent with a hot thermal origin. Upon examining the equations that govern a black hole, a remarkable observation is made. If one were to start just outside the black hole's event horizon and escape to an infinite distance away, their distance from the black hole, r, would go from the Schwarzschild radius to infinity. Conversely, if one were to start just inside the event horizon and track their distance from the black hole to the central singularity, that same distance, r, would go from the Schwarzschild radius to 0. This observation is significant because all the properties of space outside the event horizon from r to infinity are identical to those inside the event horizon from r to 0. Simply replacing the distance r with its reciprocal 1r demonstrates that the black hole's interior is mathematically identical to its exterior. This is like observing a perfect mirror that reflects the entirety of the universe outside of it, albeit distorted on the mirror's surface. As our understanding of the universe has improved over the past few decades, two discoveries have rocked the foundations of cosmology. The first of these discoveries is cosmic inflation, which proposes that the universe was set up by a rapid, relentless state of constant exponential expansion that preceded the hot Big Bang. It seems as though there was some sort of field providing an inherent energy to space, causing it to inflate. Only when inflation ended did the hot Big Bang begin. This discovery challenges the previously accepted idea that the universe arose from a singularity. The second discovery is the possibility of a multiverse. Over the past couple of decades, many theoretical physicists have come to believe that our universe is not the only one. Instead, we may be part of an immense array of separate universes, each its own shining orb in the true night sky. This idea is related to Stephen Hawking's proposal that each time a black hole is created in our universe, it could give rise to a baby universe accessible only to an observer that crosses inside the black hole's event horizon. The possibility of a multiverse raises many fascinating questions about the origins of our universe and the nature of reality itself. The discovery of cosmic inflation and dark energy have shaken the foundations of cosmology. One of the fundamental differences between the two is the expansion rate of the universe that you infer depending on the class of methods you use to measure it. Some people have speculated that there might be a connection between the two concepts, and the presence of black holes could provide critical insight into the nature of that link. As the universe expands and becomes less dense, distant galaxies recede from us at an accelerating rate, behaving as though there's some sort of energy inherent to space itself. This energy does not dilute even as the expansion of space continues. One potential explanation for reconciling this discrepancy is that there was a stronger form of dark energy early on, one that existed after the end of inflation but decayed away before the cosmic microwave background scattered off of the primeval plasma for the final time. But what is the link between black holes, cosmic inflation, and dark energy? As material falls into black holes, they gain mass and decay, losing mass via Hawking radiation as the size of the event horizon changes. Could this change in the energy inherent to the fabric of space? Is it possible that what we perceive as cosmic inflation marks the creation of our universe from an ultra-massive black hole? There are mathematical pieces of evidence that suggest a connection between black holes and cosmic inflation, and many models and ideas continue to abound. The concept of black holes giving rise to their own baby universe within our universe is compelling to many who research black holes, thermodynamics, and entropy, general relativity, as well as the beginning and end of the universe. Regrettably, despite numerous attempts, no physical model has been able to make unique predictions that fulfill three critical criteria. First, to replicate the successes of the currently established inflationary hot Big Bang model. Second, to explain the observed phenomena that the prevailing theory cannot. And third, to make fresh predictions that differ from those predicted by the leading model, which can then be tested. Roger Penrose's conformal cyclic cosmology, CCC, is perhaps the most well-known attempt at doing so, and it predicts the existence of Hawking points, or circles of unusually low temperature variance, in the cosmic microwave background. Unfortunately, these features have not been detected in the data, rendering the notion that our universe originated from a black hole, and that black holes spawn baby universes purely speculative. Despite this setback, there is much to admire about the idea, and there is a physical and mathematical relationship between black holes and the genesis of universes. It is possible that an extremely massive black hole created from a prior universe spawned our own. It is also possible that each black hole created in our universe gave rise to another universe within it. However, the critical step of identifying a unique signature that distinguishes these hypotheses from existing ones remains challenging for theoretical physicists. Without a recognizable mark that sets these ideas apart, they will continue to be mere speculative hypotheses. While we cannot say with certainty that our universe emerged from the creation of a black hole, it remains an alluring possibility that would be unwise to dismiss. The quest to uncover the secrets of the universe's origins will undoubtedly continue to captivate scientists and researchers for years to come. What do you guys think about all of this? Leave a comment letting us know. Make sure to also subscribe to our channel to help us keep making these free videos. Thanks for watching.